All right, so what is the answer for number 1? Lucas?
9.
9. Why? What am I doing?
You're multiplying -3. You're squaring -3.
-3. And one more time, what is the difference between doing that versus doing this? Can anybody explain that? Evan?
The first one, in parentheses -3 and then squared, that is -3 times -3. So when it's -3 squared in parentheses, that is -3 times positive.
It's really just -1 and only 3 is squared. Because here, the base is just 3. And here, the base is the entire -3 because it includes everything in the parenthesis. Does that make sense? All right, number 2, how do I evaluate? William?
And so first you put the parentheses and you put the square outside.
And what am I putting inside?
-3.
And then the square is outside.
So
And
you do exponents first.
I don't do negative times negative?
No,
No. Big mistake people make. So we do the exponent first, and that becomes what?
9 times -1.
Good. And that ends up being good. Next one, answer, please. You can just give me the answer. How about Camille? -3. Agree or disagree? Good. Okay, and number 4, please. Let's go with Christian. -32. Agree or disagree? Good. This is the math that you will be doing for the next month. And it's little details that will cause you to go from A to F. Okay? And I mean grade, not a bad word. Okay, so here's what we are doing today. We are learning how to graph quadratic equations and quadratic functions. It is it is a lot to explain, and we are going to cover a lot of material today. There are about 10 things you need to learn, okay? Now, I've rewritten this PowerPoint slightly to show quadratic function, even though it states equation. If it were an equation, it would read y equals ax squared plus bx plus c. Y equals. I input the f of x because I want you feeling more comfortable. It's interchangeable, the y and the f of x. Are you guys understanding that? Stephanie, is that clear? All right. So what I want right now is for you to get at least one graph with the notes. Okay, one graph with the notes. We're going to go through many graphs. You really need one. And then I'll tell you when also to write. So let's look at the f of x equals x squared. As I begin to graph this, I'm going to go to my table. When in doubt, table it out. If you don't know how to graph something, make a table, pick some points, and start going. Okay? So, how do I get my x's? What do I do for my x's? William. What kinds of numbers?
One positive, like 0, and then negative.
We want to pick integers, positive, negative, 0. So I'm going to pick more than that so you can see more. Okay, now by the end I'm going to give you a lot of shortcuts, okay? So when I have -3, when we square -3, what is it equal to? What? 9. So I plot that point. I go over 3, up 9. When I have -2 squared, what does it equal? 4. Okay, so I go over 2 to the left and up 4. -1 squared. 1. And then I plot it. 0 squared. Okay. 1 squared. Okay. 2 squared. 3 squared. Now, 3 squared is 9. Okay. Now, what shape am I making? Yes.
Making like a V shape or parabola.
A parabola. It's not a V because V is more like absolute value, but we call this a parabola. And we get that when we have what kind of term? What? A quadratic term. Can anybody remind me what a quadratic term is?
It's the one that's like this.
It's like x squared. So we get this shape. Now, the thing about a parabola that's really nice is that you get some free points. I don't need to do math for all these points. Because the thing about, you'll notice, if we look at the table, you have repeating y's, right? And what that really means is that you're going to have the same thing on one side of the parabola as you have on the other. What do we call that when it's exactly the same? Yes.
Symmetry.
It's symmetry. It's symmetrical. It's the mirror image. It's a reflection. So really, I'm given some free points. As soon as I see that it's making the parabola shape, I can cut that parabola in half. I'm going to slice it in half, right? And then I'm noticing this is 2 units over right here. So I'm going to go 1, 2 units over. Does that make sense? And this one is 1, 2, 3 units. So I'm going to go 1, 2, 3. Does that make sense? So I kind of call this and this free points. I don't have to do any math work to get them. I use the symmetry to find its symmetrical mate. Does that make sense? Or ordered pair. So once I do that, I'm going to graph it, right? I've plotted all these points. I'm going to connect the dots. And I just do it by hand. Okay, you with me? Now, does anybody know what the lower point, the bottom point of the actual parabola is called? This bottom point of the parabola is called right here. Who remembers what that's called? Charlie?
The axis of symmetry?
No, it's not the axis of symmetry, but you're close. You are close. Nicholas?
The origin.
It's the origin for the coordinate plane, but for the parabola, it is the, Nathan? We call it the vertex. Remember, we talked about this in chapter 3. It is the vertex. So, when you are graphing quadratic functions or equations, you must identify the vertex. Always, always, always. So what is the vertex? What is the ordered pair that describes it, Lucas? 0, 0. And so, we are now, that's where we are, okay? Now, my question to you is, where does the parabola get sliced in half exactly so that it's symmetrical? Where does it go through, the line go through on the x-axis, Theo?
The y-axis.
Okay, but where on the x-axis does it go through? I want a specific point. Yes.
The origin.
Which is what point?
The 0.
0. It's 0 on the x number line. It's going through. So what we do is we draw that line. See how it's dashed? And we call that, everybody ready for it? Axis of symmetry. It is the axis of symmetry. Now, the axis of symmetry goes through 0. 0. It goes through 0. Are you with me? Axis of symmetry is going through 0 on the x-axis. So now, let's take a look at this. Let's look at the shape. Let's look at the equation. In the equation, do we have a y-intercept? Is there a y-intercept? What is the y-intercept? Yes.
The y-intercept
Is 0. How'd you know that?
because if it was the equation would be x squared plus 0, or if you look on the graph where it goes through the y-axis.
We see where it's going through the y-axis at 0. And if you look at the equation, since it's plus it is implied, if you don't see a number there, it is implied it is a 0. Okay, what is the coefficient of x squared? Yes, 1. Okay. All right, you guys have these notes? This should be, now we're going to look at different graphs and compare them. And what we're going to do is look for the critical features. All right, so now the last one was x squared. Look where it is. Look where we're going. What do you think x squared minus 5, how do you predict it's going to look? Alex.
It's going to look the same, except the vertex is going to be on -5 on the y-axis.
Okay, can anybody else describe more? He said it's going to look the same, except your vertex is going to be at -5 on the y-axis. Vic?
The numbers are still going to be squared. It's just that it's going to look lower on the graph.
Lower. What do we say about that? Yes.
5 below 0, so 5 down.
Okay, do you remember in chapter 3 when we were talking about, yes, but that's horizontal, is sideways. It's a vertical shift down 5 units. We're shifting it down 5 units. Well, let's see, let's graph it. So again, I'm making my table. I'm going to go quickly through the math. 3 squared, -3 squared minus 5 is, everybody? 4. -2 squared minus 5 is? What? -1. -1 squared minus 5 is? 0 squared minus 5? 1 squared minus 5? Okay, I'm seeing I have the ability to find some free points. What free point might I find? Olivia?
The point is -2, -1, I think.
So I start here and I go -2, -1. That would be here.
Yeah.
And then what would its mate be?
It would just be 2 over from the origin. Or a shift of...
She went
It
1,
would just-
2, down 1. Which way am I going?
You're going to the right. Or, yeah, my right.
1, 2. Okay, or we don't even need to go to the origin. Look at the point. Notice it's 1, 2.
Yeah.
So from that point, I'm going 2, 1, 2 from the y-axis, you would say. There's my freebie. Okay, do I have another freebie? Can anybody tell me the ordered pair of the other freebie? Okay, Vic.
The ordered pair would be 3 and 4.
3, go over +3, up 4, yes. And I'm checking that. It's 1, 2, 3. It's 1, 2, 3. Now, who can tell me what my axis of symmetry is? Burke?
Wouldn't it still be 0?
It's still 0. To slice it in half, it's still going through 0 on the x-axis. What is my vertex, please? What's the vertex? Snupfingers?
0 and -5.
0, -5. Good. And we heard our axis of symmetry. Everybody say axis of symmetry.
Axis of symmetry.
When I'm labeling it, I label it AOS. AOS equals 0. So when we're graphing these, it's not optional. We have to label the vertex and the axis of symmetry. Okay? So we saw that now our predictions came true. Can I continue? Okay. So now, what do you think? What are we predicting is going to happen? Lucas Cabay.
I think that the vertex is going to move up 4.
It's going to shift up 4. And, Irene? It's going to turn upside down. What turns it upside down?
The negative.
Good. And what is the coefficient of that first term? -1. What do we think our y-intercept is? Vic?
4.
positive 4. Let's see. So I'm going to do all the math and plot the points. Sure enough, it's turned upside down. I don't need to keep doing the math because I have free points. I'm going to do this. And I'm going to go, it's 1, 2, 3, it's 1, 2, 3. Now, you will notice every time when I draw it, I continue the angle of the line. Okay? So, the predictions were, how many, what happened to the vertex? Shifted up 4 units, and it's opening upside down. That's correct. Are you guys with me? What's my axis of, no, what's my vertex first? Olivia, vertex.
Your vertex is 4, or 0, 4.
0, 4. And what would be my axis of symmetry? How about Camille? X equals 0. Correct. AOS, X equals 0. Questions? All right. Now, what's different about this equation than the previous couple? April.
That there is a slope.
You mean, okay, close. What do you mean by that?
Yeah, with the last, it was only like x squared, but this one is x
2x squared. So what do we call that 2? Berkowitz?
coefficient.
It's a coefficient. There's a coefficient to that quadratic. Now, what do we think that's going to do to the graph? Theo?
It's gonna like
What do you think, Irene? It's going to be narrower. Well, let's see. Okay, what is my y-intercept here? David?
Negative 4x.
Be careful. In y equals mx plus b, y equals 3x plus 4. What is my y-intercept?
Positive 4.
Okay, so is there a variable with the y-intercept? No. So what is it here?
Negative 4.
It happens to have an x, so that's not your y-intercept. Who knows what the y-intercept is, Christian? It's 0 plus 0. If there's no number by itself, there is a number by itself. It actually is a 0. It's there. It's just invisible. All right, so I'm going to make this. I'm doing the math for you guys, and I'm plotting it. And let's see. I heard predictions that it would get narrower. Is it narrower?
no, sort of. I can't really tell.
Yes, it is.
How?
Well, let's go here. So here, look, we'll count. Look at it right down at the bottom. Okay? It is narrower. Look at that one. See how much narrower it is than this? They're opposite, but it's definitely narrower. Okay, so I'm doing this. What else is different? What can you tell me? What is my vertex this time? Vertex. Let's go with April. What's the vertex? Let me put it all up.
The vertex is 1, -2.
1, -2. I write the word, I write the point. Okay, what is my axis of symmetry? What is my axis of symmetry? Hayden?
X 1.
X equals 1. It's going through 1 on the x-axis. So we say the AOS equals 1. Question, yes.
Do you want us writing that dotted line
Yes. That axis of symmetry is important. Yes.
And the vertex refers to which point?
The lowermost point. The lowest point. In fact, we also call that a minimum. That's the minimum point. If it's opening upside down, what would I call the vertex? What? Loud. It's the maximum if it's opening upside down. If it's opening right up, it's the minimum. Okay, are we noticing anything also? Anything else? Yes, Evan.
The x-coordinate in the vertex is the axis of symmetry.
You make any conclusions?
I mean, if you find the axis of symmetry, you know the x value for the vertex.
Okay, let's see if that happens in the next one. All right, so on this one, this number, last one was 2 for the coefficient. The sign makes it go up or down. Which way is this opening? Down. And tell me, what's the shape of it going to be? What's the shape, Nadia?
I think it's going to be wider.
It's going to be wider. Notice the coefficient before was 2. It was greater than 1. But the coefficient here is 25 hundredths or 1/4. So it's going to be, the prediction that she's making is that it will be wider. So let me do the math and get that up here. Now, if I were doing this, I would convert this to a fraction. 1/4, negative 1/4 x squared. Because when I start substituting in, I would pick what kinds of numbers here. What kinds of numbers would we pick here? Theo.
Numbers that 1/4 goes into.
Right, so
Multiples of 1/4.
multiples of what?
4.
Of what?
4.
Multiples of 4. I'd pick negative 4, 0, and 4. Does that make sense? If I have 1/2, what kinds of numbers am I going to pick? Yes. Good. If I have 1/3, what am I going to pick? If I have 3/4, what am I going to pick? Still, whatever the denominator, multiples of the denominator. Okay, that makes it. Okay, so here I'm plotting it. And sure enough, it's looking wider. Okay, what is my axis of symmetry, Julia?
Your axis of symmetry would be 1, would equal 2.
Would equal 2. And then my vertex would be what? How about Michelle? What's my vertex? 2, 1. Okay? All right. Now I want you to write, everybody's writing this part. Ready? Okay, so now we're going to talk about the critical features of graphing quadratics, or of a quadratic equation or function. Well, the first term we call it what? What is that term called? Come on, guys. You said it earlier. What? It's the quadratic that's the quadratic term. What is the second term called? To the first power. Yes? It is our linear term. And the last term is what? Yes, what kind of term? It has a special name. It's a constant term when you don't see the variable, but it's there. It's x to the 0 power. So that is the constant term. Now, A, when it's positive, which way does it open? Good. It opens, I'm seeing hands, show me up. Okay. When it's negative, it opens down. When A, just the absolute value of A, I don't need the sign, because the sign only tells me up or down. Just the absolute value of A, what is it? The absolute value of A, if it's greater than 1, What shape will it make, Michelle? If it's greater than 1, what? Tell me about the shape.
If it's greater
Not what kind of shape, but how would you describe it? Yes.
if it's greater than 1, it would be narrow.
It's going to be skinny or narrow. And Michelle, if it's less than 1, and it has to be less than 1 but greater than 0, what kinds of numbers are those? What? Decimals or fractions. So if it's decimal or fraction, we don't have to go less than 0 because the less than shows up or down. Does it open? Okay? Anything that's a decimal is going to be a wide or a fat parabola. Yes?
Could you explain why you're doing the absolute value? Because isn't it?
Because when we had negative 25 hundredths x squared, the negative refers to going down. The positive refers to opening up.
Yeah.
So I'm really just concerned with the numerical part to tell me if it's going to be skinny or wide. If it's a whole number, if it's a number greater than 1, it's going to be skinny. If it's a number that's less than 1, it's going to be wide. Less than 0 will make it go this. So I don't need anything less than 0 negatives. That's why absolute value gets rid of it. Okay, tell me about the C. What is that? C. What is that? How about Manuk? A, right here.
C is the constant term.
Constant term. And it is the, what else? What do we get? Where does that tell us? How about the other Manuk? It's our y-intercept. Okay? If it's positive, which way does it shift our parabola? Berkowitz?
To the right.
What? Positive.
My bad, up.
Up, and negative down. Okay. Questions? Okay, you should have this for when we're having a quiz or a test or something that you can refer to it. Okay, questions? Yes.
A number greater than 1. Why is it skinnier? Like, shouldn't it?
Because the math makes it go that way. If you put it into the table, you'll see the math will make it that way. I don't choose it to be. When you plug when you substitute numbers in, and you have the coefficient is a number greater than 1, you'll see the parabola will get skinnier when you put in when you substitute your x values in. Does that make sense? Okay. So our critical features of a quadratic. I'm going to do this part. We're going to plot this. What did we say they were? Oops, I didn't mean to do that. What happened there? Shh. All right. The critical features are, sorry, I got to go. Okay. Okay, so what do I need to label every time? Fruman. Okay, what is my axis of symmetry here? Okay, 3. And what's my vertex? What is it? 3, -7, and then my axis of symmetry. So what do we notice, again, every time about the relationship between the axis of symmetry and the vertex? Julia?
Your axis of symmetry is the x and the vertex.
It is your x and the vertex. So now we are going to do this, okay? We've got all the information, well, we have some of the information we need so that we can now shortcut. So, the shortcut for the axis of symmetry is a formula. X equals negative b over 2a. X equals negative b over 2a. Now, when we have a quadratic equation, remember, look at the chart over here. Remember this? I said this is for all equations. Y equals ax squared plus bx plus c, the standard form. So what is my a? First thing you always do is identify your a, b, and c. You should all be writing this part too. Artem? Lucas?
I am ready.
What is my a, b, and c? Nadia?
Your A is 1.
Okay? Because look, my coefficient here, I don't see anything, but it's really there. It's there. It's 1. It's implied. And keep going, Nadia.
The B is -6.
Negative 6 is in front of the x term. And the c, David,
The C is 2.
2. So now I'm just substituting. Negative 6 over 2 times 1. Now, negative 6 over 2 times 1. And x is equal to 3. Okay? Now, what is 3 now? What did I just find?
Oh,
Olivia?
Your axis of symmetry.
And where else can we use that? Lucas?
On the graph.
Where else can I use that? Stephanie? For your vertex, where?
The X.
It's your x in your vertex. So I have my x for my vertex. Now I've got to find my y. Well, I don't have it, but I have the equation. And I have x. So what can I do? Julia?
You put the X into the equation.
Okay, and so I'm going to substitute in. And I get 9 minus 18 plus 2 is negative 7. And we have our vertex, which is, Evan?
It's
3, negative 7. So we don't need to do a table every time. Now we can, but you must. Here's the thing: when you label when you graph a quadratic equation, you must always label the vertex. You must always label your axis of symmetry. Now we know how to find the vertex, find the axis of symmetry. Do we know what our y-intercept is? Look at the equation. What's the y-intercept? Everybody? 2. And does it open up or down? So I've got 1, 2, I really have 3 points. Okay? Now, I'm going to show you how we use this. We're going to now take a break and go on to the worksheet. Okay. I'm going to pause it for a minute. You have this worksheet and we're all going to work on this. Now tonight for homework, the first 2 pages are just like worksheets for you to like practice. The ones that look like this are just for, there's only one and you have a back side too. The back sheet is homework. If you feel like you need this worksheet to do your homework, I'll upload this to Jupiter Grades. Okay, and you can download more of them. All right, so step 1, I'm going to give you a very easy quadratic to graph. Y equals x squared plus 6x plus 8. Okay. Step 1, what is our A, B, and C? Let's go with Artem.
A is 1, B is 6,
8. I can't. No, I can't. Okay. Now, do we know what to do with those? If we have the, let's find our axis of symmetry. I want you to do it right now. You guys go. They can? Should I do black? Is that easier to see? Okay, so pause it and find your axis of symmetry. All right, walk me through it, please. Lars.
So x equals negative 6 in parentheses over 2 times 1.
Good. Do I need the parentheses for the negative 6? No, because there's nothing else going with it. Okay. And what does that simplify to?
X equals
Negative 3. So I put it down here, and I can also use that here. Now, what am I using now? Step 3, it tells me what to do. You have the directions on your sheet. What am I doing, Nicholas?
You're replacing the x with negative 3 in the original equation.
Right, x squared plus 6x plus, what is it? 8. And we get y equals, you guys go, finish it up. Okay, give me a thumbs up when you're done. What did we get for the y, William?
-1.
Y equals -1. All right, so I've provided this little box right here to gather information. You can see it says the next step is right here. But this is where we gather information. So we are going to say it is -3, comma, oh wait, it was -1, sorry. -1. Which way does it open, please, Yasmin? Upward. Okay, that means it's going to have a maximum or a minimum? Minimum. So list that there. You want all that information. Roots, we don't know yet. Axis of symmetry, please. Axis of symmetry? Yes. Axis, yes. Minimum means the bottom point, versus if it opens up, the bottom point we call a minimum, the vertex. If it opens down, like this, we call the vertex the maximum point. Okay, I'll say minimum, maximum. It's going to be a minimum. Okay, axis of symmetry, please, Marissa.
The axis of symmetry
Is -3. And the y-intercept, Manuk,
8.
is +8. All right, so we are ready to graph this. We've got some things to graph. Okay, so what we have is our axis of symmetry, right? So I'm going to do that, and let's keep it blue, right? My axis of symmetry is what? -3. So I'm counting over 1, 2, 3. It goes through -1. And you must do the dashed line. And we're going to label that. AOS equals -3. Do I need to write thinner? Okay, tell me if this is too small. Okay, now. Okay. My vertex is where? What? Yes. -3, negative what? 1. Okay. Now, my y-intercept is 8. So I'm counting out 1, 2, 3, 4, 5, 6, 7, 8. And now notice that's 3 units to the right, so I'm going to go 3 units to the left. 1, 2, 3. Okay? Now I've got 2 more freebies. If I don't have any more, I got to make a table. I don't want to make a table. That was a lot of work, right? But look what you do have. Y equals x squared plus 6x plus 8. See what it says? Find the roots, if there are any, by factoring. Factor it and graph them. Set y equal to 0. When I set y equal to 0, what am I really finding? What am I finding? So all of our factoring was really about finding 2 more points for our graph. What multiplies to 8 and adds to 6? 2 and 4. So I'm doing x plus 4. Sorry, x plus 2. When I solve it, x equals -4, x equals -2. What is the ordered pair here? Yes. -4. No, it is not -4, -2.
It's -4, 0,
-4, 0, and the other one is -2, 0. So those are 2 more points. When you factor -4, 0, 1, 2, 3, 4, boom, there's 1. Here's 1. And now we draw it and label it. Okay? I'm exaggerating. Okay, we have to label our vertex. It's -3, -1. I've got to label my y-intercept. It's 0, 8. And you should label your roots or your x-intercepts if you have them. -2, 0. Yes, Stephanie.
So the top one, 0,
What? Wait. Shh. Hold on.
the top one comes from the y-intercept, right?
Yes. This is the 8. I'm moving how many? And it's the mate. Okay, so okay, so now let me rephrase. What are we going to label? We need an axis of symmetry. We've got it right here on the list. What else do we need, Evan?
You label the vertex.
For sure, we need to find our vertex, label the vertex. What else? Yep.
Don't you need that point on the top left?
Top right, you mean?
The vertex is
What point is he talking about?
I think he's talking about the vertex, right?
That's top. That's not top. That's on the bottom. You mean right? Right here?
We already labeled that.
Shh. No, I'm asking. When you do these on your own, what are the things you need? You need an axis of symmetry. You need a vertex. What else do you need?
Y-intercept.
Your y-intercept. And then you can pick 2 points that are either you factor to get 2 more, or you can get more by creating a table. And then just choosing a bunch of x's. So when x is 1, right? When x is 1, I do 1 squared plus 6 times 1 plus 8. What is my y going to be?
Good afternoon, Milliken Middle School. 8th grade students, you're living.
All right, so if you can't find something, you're going to choose a point, any point. I tried 1. As you can see in black, when I do that, it's off the grid. So I might try something maybe negative, like -2. -2 squared plus 6 times -2 plus 8. So -2 squared is 4 minus 12 plus 8. What's it going to be?
Oh,
Oh, sorry. I can't fudge it. Okay, it's 4. Here, I'll make the table on here. I said if I'm choosing 4, you're just making your table, guys. It's if I choose 2, when x is 2, I'm doing, x squared plus 6x plus 8. So I would do 2 squared plus 6 times 2 plus 8. Oh, let's do negative, right? So that makes 4 minus 12 plus 8.
Which equals 0.
Is that right?
Yeah.
That would be 0. So when x is negative 2, which is already on there, I chose the y-intercept. I shouldn't have done that. Or no. No, I didn't choose the y-intercept. I choose one of the roots.
But it's more accurate to use
But
the
when
factoring.
The factoring's faster because you're good at factoring now. If it's easy factoring and there's no lead coefficient, so the question is that that Olivia asked is, what if the point I picked does not show up on the graph? Pick another one. Yes, Stephanie. Well, the roots are your x-intercepts. That's what we got from factoring, right? We got this. So my last thing before you walked out of the classroom was, well, what do I get from factoring? What am I getting from factoring? Olivia?
You're getting the x-intercepts?
X-intercepts. So what happens if you can't factor, if it's unfactorable? What happens if it's unfactorable? Okay, yes?
Use the table?
Okay, we have to use a table. What happens? What's happening in that situation? What do I get from factoring? One more time, everybody.
The x-intercept.
So if it's not factorable, what am I not getting?
An x-intercept.
So what's it going to look like?
It's going to be a straight horizontal line.
No, it's not going to be a straight horizontal line. Nadia?
Would the vertex be on that?
No. It's going to be floating. Because it's not crossing, or it'll be something like that, or like that, or like this. So when you get a graph like that, then you just, if it's not factorable, and you use all our rules, then you jump down and start using a table. You can still graph it. But at this point, especially for this problem, this was the easiest possible situation. Yes?
It would also be just somewhere like on the y-axis, like say that, say it was, x squared plus 3 or something like that, so it would be 3 up, so it would never touch it, yeah.
Yes. X squared plus 3 will not touch, and that's not going to be factorable. Yes, Vic?
Those are parabolas, correct?
They're supposed to be, yeah.
Well, if they're parabolas, aren't the lines always at an angle? So
Yeah.
wouldn't it be eventually?
But they're never, if it's going up and it's above the x-axis, it's not, okay, I need the talking to stop. All right, so let's do one more. Can I erase this? Now, do you have to factor and table?
No.
No, it's one or the other, right. All right, so let's try another one. Oops.
No. On the back?
Oh, darn it. Okay, I'm going to try one more. Shh. I need a worksheet. Okay? I'm trying. Sorry about this. I don't know how I got this last time. All right. So, guys, shh. Now, we're going to do this one. You'll see it'll go much quicker. I'm going to pick, I want you to see just one other scenario. So let's do y equals x squared plus 7x plus 10. Okay, what's my A, B, and C? Evan?
Your A will be 1,
Shh.
B will be 7, and your C will be 10.
Good. Next, if I do my negative b, guys, find the axis of symmetry. Go. Okay, give me a thumbs up if you have it. All right, now, look here. If I have a decimal like this, look what I'm going to do. I like to work in fractions. I'm going to kind of write on top of my. So remember, I'm using y equals x squared plus 7x plus 10. So I'm going to use that in fraction form. Negative 7 over 2 squared plus 7 times negative 7 over 2 plus 10. Okay? I know, I'm going to bring it down right now. So, negative 7 over 2 squared is what? 49 over 4 plus, negative plus 7 times negative 7 halves. What is that? 7 times negative 7 over 2. Negative 49 over 2 plus 10. Now, I need a common denominator, right? So I'm going to multiply this by 2 over 2. And this is being multiplied by 4 over 4, right? So then I have 49 over 4 minus what?
98.
Over 4 plus 40 over 4. And what does that simplify to?
Negative 11 over 4.
No.
Negative 1, 4.
Negative 9. It's negative 9 over 4. Because it's 89. 98 minus 89 is negative 9. And that, if I divide it, 4 goes into 9 2 times. I have a remainder. Goes 2 times 8, 1, and it's 1/4. So 2.25, and it's negative. Now, I wanted to show you this because these are awkward numbers, right? When that linear term is odd, you're going to have decimals and fractions, but it's not the end of your world. So let's do, my vertex is negative 3.5, and my comma, negative 2 and 25 hundredths.
You don't want us to turn it into a fraction
No, because I know where these are.
on the...
Number line better, right? I don't know where 9/4 is, but I know where 2 1/4 is. Okay, which way is it opening, guys? It's going up. There's going to be a minimum. Okay, my axis of symmetry is
Negative 3.5.
negative 3 and 5/10. My y-intercept is, yes. Okay? 10. Or 0, 10, right? You can write it either way. Now, is it factorable? Y equals x squared plus 7x plus 10. Okay, so what does it factor to? What multiplies to 10 and adds to 7? Okay, so it's x plus 5, x plus 2 equals 0. And so my x equals negative 5, x equals negative 2. What is the ordered pair? Burke?
Negative 5 and 0
negative 5, comma 0, negative 2, comma 0. So my roots are negative 5, comma 0, and negative 2, comma 0. Now I'm ready to graph. I have, look at how many points I have. 1 point, 2, 3. Here is 4, and I get its symmetrical counterpart. So that's 5. 0, comma what? No, because it's the x-intercept. When y is 0, we said when y is 0. So, now, this is what gets kind of funky. My axis of symmetry is negative 3.3 and 5/10. 1, 2, 3. 2, 3. And now I'm going to do 1, 2, 3. I'm going right in the middle. Do you see that? You can estimate it. That's why I keep it in decimal form. Okay, there's my axis of symmetry. You should be doing this, not just sitting there. Negative 3 and 5/10. My vertex is what? Negative 3.5. Then I'm going to go down 1, 2, and just a little bit. 1, 2, and a little bit more. Do you see how I just put it under there? Are you with me? Okay, 1, 2, and a little bit more. And now, what am I going to do? What else can I do? So I'll just label that right now. That's negative 3 and 5/10, comma, what was it? Negative 2.25. That's my vertex. Okay. What else do I have to graph, Catherine?
You graph the y-intercept.
The y-intercept, which is what?
0, 10.
0, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I really should continue my axis of symmetry all the way up. Okay. Now, it's 3.5 over, so I'm going to go 1, 2, 3.5 to the opposite side too. And I'm going to say that was, what was it? What ordered pair is the y-intercept? 0, comma 10. And I'm going to say there's the y-intercept. And now I've got 2 more points. You've got 2 more points, Hayden. The roots or the x's or the intercepts. There's 3 names for it. Okay? And so that is negative 2, 1, 2, 0. And I also have negative 3. Oh, that's negative 1, 2, 3, 4, 5. And now I can draw it. Are you guys with me? So I'm going negative 2, comma 0, negative 5, comma 0, accent, accent, and now I'm trying to draw on this iPad, which is really difficult. Okay. So do you understand when we get decimals, not to freak out? Okay. Now, one last thing. Tell me about the range. Describe the range. Irene.
It's greater than or equal to
What is?
r.
What variable? Y is greater than or equal to? Negative 2.25. Tell me about the domain. Tell me about the domain, Christian.
Domain is
All
all real numbers.
real numbers. Okay, I'm going to stop the recording. That should be it. Now, you are doing the last page at both sides for homework.
Why all real numbers?
Huh? If you get, you don't, shh, one more time. That last one, do I need to do the table? No, you only need really 3 points. The vertex, the y-intercept, and one other.
So we don't feel labeled.
You don't need to. It's x. Shh. I can't answer this question over and over. What? Well, really, you should label your x-intercepts if you have them. That will give you 4. Yeah. Shh. Let's start. Can you stop talking? Evan, you're keeping April from doing what she needs to do, and I'm going to hear about it from her mom. Yeah, when she can't do it on the test. Okay, what did you say? Okay, so let's look at that. Shh. Okay, what does it say? Use A. So what is my A here? First of all, what's my A? 1. What's my B? -4. And what I have such a small space, I don't know if I need a very fine marker. And I don't have one. And what's my C? It's 8. Does it open up or down? Good. Is the vertex going to be a maximum or a minimum? Huh? Minimum. What is the y-intercept, please? Burke?
0,8.
8. Axis of symmetry. X equals -. -b over 2. Oh. I have not one. Oh, here we go. -b over 2a. Okay? So what is that? Negative what? -4 over 2. So it's 2. Right? Axis of symmetry is 2. So my vertex there. Now, 2 squared. 2 squared is what? 4 minus what? Plus 8. So what's my y going to be? It's going to be 4. Okay, so I'm going to plot that. Shh. What? Is that wrong?
Don't you get 2 answers when you do that?
Shh. My vertex, my axis of symmetry is 2. So I'm doing this. Okay? I've got my vertex, which is 2 squared. Sorry, this should be, x is x 2? 2 squared is 4, minus 8 plus 8. So it's 4. So 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. Shh. Okay, we said it opens up, right?
Yes.
Now, what's another one I can do? Another point I can plot. What? The y what? Y-intercept, which is 0, 8. So that's 4, here's 8, right there. And its symmetrical mate would be 1, 2 over. Now, I need 2 more points. I can do a table. I can just say what happens when x is 1. Right? When x is 1. What's 1 squared? So when x is 1 squared plus minus 4 times 1 plus 8. 1 minus 4 is what? Minus 3 plus 8 equals 5. So when this is 1, 5. So when x is 1, it's 1, 2, 3. Wait. 1, 2, 3, 4, 5.
Here's the numbers.
And this one could be, it's just 1 over. And then I can graph it.
So what's the use A mean?
Okay, so use, what they're saying, use A when x is 1. What is this point? Huh? I think this is, we're doing, the vertex is, okay. Use A to find points 1 unit to the left or right of the vertex. Use A to find points 1 unit left or right of the vertex. What does that mean?
Does it mean the roots? Does it mean the roots?
Oh, that's what
I
was-
think,
that's what I
no,
was-
there's no roots.
Yeah,
It's just this. This is 1 unit left or right.
So we just write down that when it say use A.
I think it's this.
So we just write that down.
When x is 1, so let's go, what would this be? 1, 5, and the other one will be? 3, 5.
Oh, and that's just using your thingies of symmetry?
Yeah, they're just trying to get you to use your symmetry. Shh, yes. Yes.
Well, I feel like it's not what I was saying to you right after class. I was like, you just use the quote. The first point you can get. So the one, then you'll automatically combine them.
Oh, so they're saying use the slope.
And you can get your first point. Which is what I said.
Is that going to work on all of them? Let's see.
They asked the question.
So did you hear what he's saying? He's saying that this is like the slope. So I'm going to rise 1, run 1. Rise 1, run 1. But will that work with everyone is what I wonder.
And that's the
1 unit left or right of the vertex.
Well, someone graphed that one is equals 2 over 1.
Well, see what happens when you use 1 here once you've graphed it.
What do you mean?
Now, does this have roots? Does this have roots? So what did I resort to? What method am I using here? That's the table. I just did a small version of it. I only did 1 point. Now, well, no. We're not going to, let's do this one. This is factorable. That you should be able to factor. Huh?
It is the slope. Because I plugged the number, I plugged x equals -1 into the second equation, and I got -6 for the y. And since the slope is 2, it's up to...
So that it would be up to over 1.
Pardon
So
this
I think
interruption.
this one is
Teachers, just
slope.
reminding you once again to submit attendance. It's the last day of the month, and we still got about 1,800 students on the game.
I mean, it works on all of them.
On 1, 2 that you've done.
Well, the next one's
I want you finding this. That, if you want to try that after, what I taught you here with this worksheet is what I want you doing, those things. You must do this. You must do this. You must do this. Find the vertex.
What does it mean by use A to find points 1 unit LR?
Left or right. Don't worry about it.
But no, what is
Now, if you... Shh. Okay, Nadia, how are you?
Good.
Yeah, do you understand it? Yeah. Who is not understanding? Don't worry about that.
So we don't have to fill that out?
Yeah.
Okay. Thank you. And
Don't worry about it. They're going to do it.
And the dotted line is where the vertex is.
This
where
is
you
my
draw-
axis. And remember, guys, you must label. Happy Friday night. Okay. Or the main, yes. But not the roots. If you can factor it, I want you to factor it.
So I can either use symmetry or the roots or the factor. I will try GPS. I can
factor table to find. Okay.
So we write the roots here?
No.
Do you leave it?
You know what? You're right. I should have used. Yeah, but I mean.
Guys, math count. You see how extra I am?
This one, but that's really factoral. Yeah, this is factoral. You should have factored. Of course, you have to. Not after school.
Oh my god, you guys broke my back.
You just have to. You just have. I'm so sorry.
Hi, Michelle. No, it's okay. It's great that you're touching my heart.
All go outside.
Yes, you're yeah. Promise it allows your food. So you can tell him. I will tell him that. Yes.
We're doing a ton. Any you guys in 5th period? I forgot to say. Did I tell you I'm here if you want to stay after school and work? I am, but I mean I can go next door once they get started. You don't have to put chairs up.
Why do you set it equal to 0 again? I've always been kind of confused.
For any kind of, remember last year when we started graphing, one method of graphing was through using intercepts. When you set x equal to 0.
I don't want to do anything on this.
Oh, are you guys doing quadratics today? We went up for quadratics.
So this would be 0, 2. When I set y equal to 0,
Oh, so you can basically get rid of the x, so you can solve.
we're not getting rid of it. We're saying our intercepts are at 0. When it's 0, right? This is my graph. To be here, so I'm going to graph, hold on, sorry.
Oh, because if you did any number greater than 0, it would give you.
Well, I'm looking for an intercept. To get an intercept, look, 0, 2. 0 across, 1, 2. See it? And that's a y
Because an
intercept.
intercept needs to have 0 and then.
And to get the x intercept, I set y equal to 0.
Okay. Okay. Thank you, Ms. Armstrong. Are we on the team or are we not?
Okay, we got a lot to do. We got to take a picture.
We have to take a picture.
Okay, guys, we got to take a picture. I need you to all sign it out. No, you're not taking justice. I don't care. We're all taking this general picture together. We worked as a team and we are going to do it. But wait, we need to wait for them all to get He should be here. Yeah. Because it's a team. It's the whole club. Alright. They've been doing the club all year. I'm putting theirs in here. It is separate.
Abner Lopez, please report to the special ed office. Abner Lopez, please report to the special ed office.
All right, guys. Yes, there's math counts. Don't leave. We're trying to take a picture, and people are waiting for us.